And now we can loop over to non-determinism. All right? And what is non-determinism? Descartes was all about if we knew the exact state of the universe, is everything deterministic or not? Right? Newton says if you know where every particle is, then you can calculate where every particle will be next. So it's all deterministic. And then philosophers said, then we don't have free will, right? Can't make choices. So anyway, here we're going to have a machine that can make a choice. All right? And so free will versus determinism, right? So how are we going to... So there are a bunch of books you can be reading on this, and they make very formal definitions, and I try to make just formal enough so that you can get what's going on. All right, here, what's the delta function? It says if I'm in a particular state and I read a particular character, in a DFA, deterministic machine, it's determined which state you go in next, right? But in a non-deterministic machine, there's a set of states that you can go in next. Right? Does that make sense? And I'm using that notation to mean a set of states. The book would say, if this is my set of states, then they might write something like this to mean a set of states. But we don't need to, this works. Everybody kind of follow that? Right? Here's the thing about, he's talking about free will and he pisses his boss off. All right, so here's an example of a DFA, of an NFA. Why? Because if I'm in this state and I get a 0, I can go this way, or I could stay here. Right? That makes it an NFA. Another reason it makes it an NFA, if I'm in this state and I get a 0, then I implode. Right? Which in a DFA, for every state, you need a 0 edge and a 1 edge. Right? Here we have a 1 edge, but we don't have a 0 edge. Right? So both of those things make it an NFA. And so if you get a 0, you follow that, or you could go that way. Right? And so I often talk about fairy godmothers because I think it's helpful to have some sort of story or that's going along with this. Right? We could certainly write it up all very formally where we don't have any fairy godmothers, but it might help you. All right? So what do we need? Here's sort of a definition of when does this machine accept a string versus when does it reject. Right? Remember, a string, there could be many paths it follows. Right? And some of those paths might lead to accept states, and some of them may lead to reject states, and some paths you might implode and you don't get anywhere. Right? So that's not a very good path at all. So when do we accept? What we want to say is that for every possible string, we're either going to get a yes or no. And when do we get a yes? We get a yes if it's in the language, we want a yes. Right? And when does it do it? Is that there exists a path to an accept state. Right? So that's a formal definition, right? The machine's going to say yes if there exists some way. Now, there are many directions you could go. And how do you find that way? Well, the formal definition doesn't care how you find it. It just says that it exists. All right? Now, why do I bring a fairy godmother in it? It's because she's a good one, and she will tell you which way to go to find it. Right? Does that make sense? Now, the complement of this is if it's not in the language, we want to say no. Right? And when do we say no? Is we're saying no when there doesn't exist a path. Right? There are no paths. There are paths that go to reject. There are partial paths that die. But there's no path labeled with the alpha that gets to an accept state. Right? And the intuition there is, Well, even if you had an evil fairy godmother helping you, there's no way she could make you think that it was a yes. Right? There's no path. So she couldn't lead you in a direction to a path. Yeah? No. Well, the no instances, for every path that you follow, right? For every path you follow, it's going to either die out or reject. Right? Those are the no instances. For the yes instances, some paths might go to reject. Some paths might go to die out. But there's at least one path that accepts. All right? People get the definition? Right, so here's just, you can read the comics. I don't know, I stuck them in. All right, so here's a machine, right? And I guess it doesn't tell you what language we want to accept here. Let me tell you, the language is the same language as we had before. It contains 0101. All right? So we say a string is accepted if there's a path to an accept state. All right? So here's a string, right? On this string, are we going to say yes? Well, there are a lot of paths, right? I get a 0. I could go forward or I could loop, right? I could go forward or I could loop, right? And then at some point, suddenly I get a 0, I'm going to decide to go forward, right? So I read the 0, 0, now 0, I go forward, 1, 1, 1, and then I self-loop for a while, right? Everybody follow that that's a path that you could follow, right? So we accept that guy. Now this string will have many paths that die out, or many paths that land on a reject state. But it contains a path that accepts, so we're going to accept it. Right? Everybody kind of buy that? Right. Now here's a path, right? That's another path that this string could follow. Right? And it lands on a reject state. And it's okay to have paths that are reject states, right? And I often talk about witnesses or proofs, right? The path that lands on an accept state is kind of a witness or a proof that it accepts, right? How do you prove to me that this machine accepts? I give you a path that gets there, right? The fairy godmother gives you the path, and you check it, and you see, yes, it accepts. Right? Does that make sense? So here's another string, and you'll note it doesn't contain 0101, whichever it is. Right? So you can see, you can try various things, and whatever you try, you die. Right? Can everybody buy that on this input, there's no way to get over here? Right? So what's our language? It's the language of, sometimes they do alpha and sometimes they do omega. There's no difference. They're just different Greek letters. Right? It's the set of all 01 strings that contain 0101. Right? So, yeah? That's an accept state. Double circles means when you get there, you accept. Yeah, before some of them were, all the double circles were accepts, all the non-double circles were rejects. Everybody kind of following this? Right? And so I think if the answer is yes, then the fairy godmother is going to show you the path. Right? But if it's a no, there's nothing she can do to help you prove to it's a no. Right? You have to, how do you know there's no path? And that's going to come up later when we're doing NP versus, if for the yes instances, there's a witness, and for the no instances, there's not a witness. Yeah? No. The machine only defines that if I'm in this state and I get this character, then it names a set of states that it could go into. Right? It could go into, and then how do you know? I mean, it's a weird machine because it doesn't really know how to compute. Right? So, and we're claiming if there exists a path that leads to an accept state, then we're going to say yes. And if there doesn't exist the path. Right? So it's kind of a funny machine, but later we're going to compile this machine into a DFA. Right? And the reason we're able to compile it is because we only have a finite number of states. And as we compile it, the number of states, if it had S states, now we're going to have 2 to the S states. But we don't know how to compile non-determinism in other. Everybody good? Okay. Yeah.
So in your first step, you go straightforward into rid of 0, or your loop into 0 or 1. So if you got a 0, what do you do?
Well, that's what I'm saying. It's a non-deterministic step, so we don't know what to do. So here's various things that you can say we do. You could say that we have lots of clones, and whenever there's a choice, you clone them, and the clones go different directions. Or you could say, I have a fairy godmother, which tells me which way to go. Or you could do a depth first, breadth first search and try to find out, is there a path? I mean, we're asking, is there a labeled path from this node to that node? Right? We can do depth first search, breadth first search, Dijkstra's algorithm for finding paths. Right? I mean, there are ways of handling this. Right? But how to find the path isn't actually part of the topic. The topic is, if there's a path, then we say yes. If there's not path, we say no. We don't need to worry about how do we find the path. Right? But we might have to, but on the other hand, if I want you to prove to me what this language computes, then when it's a yes instance, you have to prove to me that there's a path, which in some ways is the same as finding a path, right? And when the answer is a no, you have to prove to me that there's not a path. So it's a little hard.